Hello students, in this video we will discuss three theorems on circle. This is chapter 10, class 9 mathematics. Theorem 10.5. Circle through 3 points. The statement of the theorem is there is one and only one circle passing through 3 given non-collinear points. So here it is given 3 given non-collinear points. First we have to understand what is meant by non-collinear points. So here you can see a line. These 3 points A, B, C are on the line. So these 3 points are called collinear points. So collinear point means the points which are lies on the same line. So non-collinear point means the point which are not collinear, that we called as non-collinear points. So here A, B, C, 3 non-collinear points. If you join these 3 points, you will get a triangle. Now the theorem is through these 3 points A, B and C, we can draw only one circle passing through all these 3 points. So I repeat the statement, there is one and only one circle passing through the 3 given non-collinear points. A unique circle passes through 3 vertices of a triangle ABC called as the circumcircle. This circle we called as circumcircle because the circle is circumscribing the triangle ABC. And the center and radius are called the circumcenter and the circumradius of this triangle. This circle has a center and this center is called circumcenter. Circumcenter, and this circle we can find out the radius. Or suppose the center is O. Suppose the center is O, then you can join OA. You can join OA, OB and OC. So we are joined here OA, OB and OC. This OA, OB and OC are called the radii. So OA is called the radius of this circle, and for this circle we call these are circumradius. So OA, OB and OC, they are circumradius of this triangle. So I hope you understand what is non-collinear points and what is circumcenter and what is circumradius. So I repeat, non-collinear points mean the points which are not collinear. Now we will move to the next theorem, Theorem 10.6. Theorem 10.6 statement is equal chord of a circle or congruent circles are equidistant from the center or centers of the circle. So first we have to understand the statement. Here it is given a circle with center O and 2 equal chords AB and CD. Here you can draw the figure. You can draw 2 chords AB and CD. So these 2 things are given. We are given a circle with center O and 2 equal chords. That is important. The equal chords. The chords are equal. So you can underline these 2 equal chords. Then we have to prove OP equal to OQ. That means the distance of this chord from the center are equal. Here OP is the distance of the chord AB from the center. Here OQ is the distance of the chord CD from the center. So we have to prove OP equal to OQ. So for proving we have to construct here, first you have to construct OP. OP is here. So OP is perpendicular to AB and OQ is perpendicular to CD. Then you have to join here OA and OC. I have already drawn, so you have to join this OP is perpendicular to AB and OQ is perpendicular to CD, and join OA and OC. So that we will get two triangle OAP and triangle OCQ. Now we will come to the proof. In the proof we will take two triangles and then prove that these triangles are congruent. As in previous theorems, here also we are using the concept of congruency. So in these two triangle OAP and triangle OCQ, we can write OA equal to OC. OA and OC are radii of the circle, and angle OPA equal to angle OQC equal to 90 degree. So these two are 90 degree because we construct OP as a perpendicular to AB. OP and OQ are perpendiculars. So the angle is 90 degree. And again you can write AP equal to CQ. And we know that the perpendicular drawn from the center of a circle bisect the chord. That is the theorem we have proved earlier. That is, the perpendicular drawn from the center of the circle to the chord bisect the chord. So here P will be the midpoint of AB. So that AP equal to BP. Similarly, OQ is a perpendicular from the center bisect the chord. Therefore, Q will be the midpoint of CD and CQ equal to DQ. So here we can write AP equal to CQ because AB equal to CD. It is given in the theorem two equal chords. So that here AB equal to CD, that implies half of AB equal to half of CD. That is AP equal to CQ. So here you can use Rhs Congruence Condition. In these two triangles, here you can see OA is the hypotenuse and second triangle OC is the hypotenuse. So these two hypotenuse are equal, and one of the side AP and CQ, they are also equal, and this angle is 90 degrees. So by Rhs Congruence Condition, triangle OAP is congruent to triangle OCQ. Now by CPCT, you can write OP equal to OQ. OP and OQ are corresponding part of congruent triangle. So this is we have to prove OP equal to OQ. So we have proved equal chords of a circle are equidistant from the center. Similarly, we can prove if there is congruent circle. You understand what is congruent circle? Congruent circle means if two circles have same radii or two circles having same radius, they are known as congruent circle. So if there are two congruent circles, then you can use the similar process, then you can prove the theorem. This is about theorem 10.6. Now we will move to theorem 10.7. Theorem 10.7, it is a converse of theorem 10.6. So here the statement is chords equidistant from the center of a circle are equal in length. That is, suppose here in the figure a circle with center O, here AB and CD are two chords. It is not given here equal chord, here only given two chords, and we have to prove that these chords are equal. Distance OX and OY. OX means the distance of the chord AB from the center, and OY means distance of the chord CD from the center. These distance are equal. That is, OX equal to OY. Then we have to prove AB equal to CD. So here we can write, given a circle with center O and two chords AB and CD equidistant from the center of the circle. Equidistance means OX equal to OY. and we have to prove AB equal to CD. Now we have to do the construction here. So here we have to draw OX perpendicular to AB. We have already drawn here, so you can write OX is perpendicular to AB and OY is perpendicular to CD. Then join here OA and OD. Or we can join here OB and OC also. We can prove it the same way. So I have joined here OA and OD. So we will continue here. In proof, we can write in triangle AOX and DOY. We are considering these two triangles, triangle AOX and triangle DOY. In these two triangles, we have angle OXA equal to angle OYD equal to 90 degree. Because of construction, OX is perpendicular to AB and OY is perpendicular to CD. Now OA equal to OD. They are radii of the circle, so they are equal. And OX equal to OY. OX, it is a distance, perpendicular distance of AB from the center, and OY is the perpendicular distance of CD from the center. They are equal. It is given in the statement. So here again you can use Rhs Congruence Condition. So look at the triangle here. OA is a hypotenuse in this triangle AOX. And here OD is the hypotenuse of the triangle OYD. So OA equal to OD. So hypotenuse are equal, and one of the sides OX equal to OY. That is the second condition. And the third condition, one of the angle is 90 degree. So these three conditions are satisfied here. So we can use Rhs Congruence Condition, so that we can write triangle AOX is congruent to triangle DOY. Therefore, AX equal to DY by CPCT, or corresponding part of congruent triangle. Now similarly we can write, or we can prove XB equal to YC. Here XB equal to YC. For proving that, you have to join here OB and OC. Then using congruency, you can prove BX equal to CY, or XB equal to YC. Now we have to add these two. First one here AX equal to DY, second one XB equal to YC. By adding here, we will get AX plus XB equal to DY plus YC. So AX plus XB is AB. Look at the figure here, AX plus XB, you will get AB, and here DY plus YC, you will get DC. So here AB equal to CD. This is, we have to prove AB and CD, they are chords, so they are equal. So in this theorem we have proved chords equidistant from the center of a circle are equal in length. I hope it is clear, these three theorems. The first theorem we have learned only the statement. For class 9 the proof is not required, so we will discuss only the statement of the theorem. So if you have any doubt, you can send the message, or you can make the comment in the comment box. Thank you.